We are about to explore the most powerful learning machine on the entire planet. And no, it's not some supercomputer locked away in a secret lab. It's probably just napping in a crib right down the hall. So let me ask you a question. Think about your days so far. All the meetings, the emails you read, the conversations you had. Now be honest. Who do you think learned more fundamental stuff about how reality actually works? You or a baby? Yeah, our money's on the baby. And you know what? It's not even a fair fight. An infant's brain is an absolute discovery engine, forging thousands of new connections between neurons every single second. They're not just learning facts, they're building the entire architecture of their mind at a speed we can't even comprehend. So today, we're going to try to see the world through their eyes. We're going to piece together how they take that initial, what seems like a chaotic blur of light and sound, and turn it into a rich, ordered, and even predictable universe. It's a journey from pure static to deep understanding. But before we start that journey, there's one really important thing to keep in mind. Every baby's path is a little different. A ton of the research we're going to talk about comes from what scientists call weird cultures. Now, this gives us a fascinating snapshot for sure, but it's just one version of the story. Developmental timelines can look very different all around the world. So no matter where a baby is born, how do they even begin to build that world? Well, it all starts with solving a huge problem: how to turn all the noise and chaos out there into a clear signal. Okay, so you've got two key ideas here. On one hand, you have sensation. That's just the raw data, light hitting your eyes, sound waves hitting your ears. But on the other hand, you have perception. And that is your brain's magic trick. It's the incredible work of organizing all that raw data into something that actually means something. The first time you heard that, it was just noise, right? A jumble of sounds. That's sensation without perception. The second time, though, your brain knew the pattern. It performed a tiny miracle and turned that chaos into language. That incredible leap from noise to meaning, that's what a baby is doing every single second of every single day. And this isn't just about hearing. For a newborn, the visual world is a completely different place. Their eyes are still developing, so they only capture a tiny fraction of the light an adults can. They literally don't have the hardware yet to see a sharp, colorful world. Their brain has to build a picture of reality from a really fuzzy signal. This whole idea is perfectly shown in the classic visual cliff experiment. And it turns out babies aren't just afraid of heights. It's so much smarter than that. They actually have to relearn what a drop-off means every time they learn a new way to move. I mean, the world looks really different when you're sitting versus when you're crawling. So it's not about fear. It's about constantly updating their mental map of the world as their body changes. And that constant relearning brings us to a really crucial point. Babies are not passive observers, just sitting back and waiting for information to come to them. No way. They are active explorers, learning about the world by physically moving through it and touching everything. This timeline shows a pretty typical progression, but remember, these are just averages. In some cultures where babies get a lot more freedom to move, they might sit or walk months earlier. It's a perfect example of how experience literally sculpts their physical development. Okay, now for a little scientific mystery that had researchers stumped for years. Newborns have this incredible, almost robotic stepping reflex. But then a couple months later, poof, it's gone. So where does it go? For decades, the accepted theory was pretty straightforward. The idea was that the brain's cortex was maturing, and it just switched off the reflex to make way for more intentional movements. A simple, top-down explanation. But then, a researcher named Esther Thalen discovered the real reason is way more down to earth. It's not about the brain, it's about their adorable, chunky legs. They just get too heavy for their little muscles to lift against gravity. And the proof? You put those same babies in a tub of water, and the buoyancy helps support their legs, and like magic, the stepping reflex comes right back. So, we've seen how babies build a world through their senses and explore it with their bodies. Now let's get into the incredible cognitive tools they use to find the patterns in all that data they're collecting. This experiment is just brilliant. It shows us that babies are not mindless copycats. When an 18-month-old watches an adult try and fail to pull a toy apart, they don't imitate the fumbling hands. No, they figure out the intention, what the adult was trying to do, and then they do it right. They learn from our goals, not just from our flubs. All right, let's talk statistics. Yeah, you heard me. Babies and statistics. Imagine a big box full of ping pong balls. It is almost entirely full of red balls with just a few white ones thrown in. Now, someone is going to pull out a handful. And here is the mind-blowing part. When the handful is mostly red, which is what you'd expect, the babies get bored pretty quick. But when the experimenter pulls out a super unlikely handful, mostly white balls, the babies just stare and stare. They're surprised because that outcome breaks the laws of probability. They're not just watching the world, they're making statistical predictions, and they get confused when reality doesn't match the odds. And they're incredibly efficient about it. Babies are basically the Goldilocks of learning. They instinctively ignore things that are way too simple and boring or things that are way too chaotic and random. They are naturally drawn to the stuff that is surprising, but not too surprising, that just right zone of information that is perfectly set up to teach them something new. And this is the real key here. Babies are not passive little sponges. They are active scientists. When they see something that breaks our predictions, like a toy that seems to float in midair, they don't just stare, they test it. They'll grab that toy, bang it on the table, drop it. They run experiments to figure out the real rules of the universe. All of this active, scientific learning has a massive, permanent effect. It physically wires their brain, turning this general-purpose learning machine into a specialist, one that's perfectly tuned to its specific environment. All right, take a good, hard look at these two monkey faces. I'll give you a second. To you and me, they probably look pretty much the same. But to a 6-month-old infant, the difference is as obvious as night and day. You probably struggled with that, didn't you? And that's because your brain has become a specialist through a process called perceptual narrowing. As you got better and better at telling human faces apart, your brain literally pruned away the ability to easily tell monkey faces apart. You've traded a general skill for a highly specialized one. And that just leaves us with this fascinating question. Your brain was built by your earliest experiences, sculpting itself to fit the specific world you grew up in. It really makes you wonder, doesn't it? While your infant brain was so busy learning to see human faces and understand language, what other incredible abilities, like telling monkeys apart, did you learn to let go of? What else did you learn to ignore?